On April 13th, 2029, a rock from the depths of the solar system will pass so close to us that half of humanity will be able to see it cross the sky with the naked eye. Its name is Apophis, a dark asteroid as wide as a 370-meter skyscraper, racing through space at a staggering speed of nearly 19 kilometers per second. That day, it will fly over our planet at less than 32,000 kilometers from the surface, closer than our telecommunication satellites. An infinitesimal distance on a cosmic scale, a simple miscalculation, and the trajectory could turn catastrophic. It sounds like the plot of a science fiction movie, but this is not a movie. It's a real event, already scheduled and marked in our astronomical calendars. It all began on June 19, 2004, in the mountains of Arizona. A team of astronomers at the Kitt Peak Observatory noticed an unusual point of light moving slowly against the backdrop of stars. After several verifications, the object was given the provisional designation 2004 MN4. A few days later, it was officially named Apophis, after the serpent of chaos from Egyptian mythology, a being that, each night, tries to devour the sun, a symbol heavy with meaning. At first, this discovery excited the scientific community, but that excitement quickly turned into concern, because the first orbital calculations revealed a significant risk of collision with Earth during its predicted flyby in April 2029. The initial probability reached 2.7%. That may seem small, but for astronomers, it's enormous, enough to make Apophis the most threatening celestial object ever observed. The media seized upon it, proclaiming the end of the world. While scientists debated, should we prepare for the unthinkable? In the following weeks, new observations refined the calculations. As the data accumulated, Apophis's trajectory seemed to drift slightly away from Earth, a temporary sigh of relief, because the numbers kept changing. The predicted path shifted with every new measurement. No one could yet say with certainty that we were out of danger. And for good reason. Asteroids are not stable objects. They are influenced by tiny, almost imperceptible forces capable of altering their course over the years. One of them, called the Yarkovsky effect, acts as a subtle pressure. When the sun heats one side of the asteroid, the re-emitted heat in space creates a minuscule but constant push. Over decades, this force can shift an asteroid's trajectory by thousands of kilometers. Add to that the gravitational perturbations of nearby planets, particularly Earth and Venus, and you have a perfect cocktail of uncertainty. In this context, predicting an exact position for the year 2029 is almost like divination. In response to the alert, observatories around the world joined forces. Each night, telescopes tracked Apophis, following its course among the stars. Positions were measured, compared, and recalculated. All this data flowed to the Minor Planet Center of the International Astronomical Union, where it was integrated into models by NASA and ESA. Little by little, the picture became clearer. The corridor of uncertainty narrowed. Powerful radio telescopes at Goldstone and Green Bank beamed radar waves at the asteroid, measuring its distance and velocity down to a fraction of a second. Thanks to these observations, scientists were able to state that in 2029, Apophis would not strike Earth. Let's imagine, just for a moment, that the calculations were wrong, that the trajectory shifted, that Earth ended up directly in its path. The impact would be devastating. With its 370-meter diameter, Apophis would release an energy estimated at 10 to the 19th joules, the equivalent of 2.4 billion tons of TNT. But even if the immediate danger seemed averted, the object remained under close surveillance, because its passage will be historically close. The shock would instantly obliterate everything within hundreds of kilometers. Cities near the impact point would vanish. The heat wave would ignite fires across vast regions, and the shock wave would make the entire planet tremble. If it fell into the ocean, massive tsunamis would rise, flooding entire coastlines. Such an impact would not cause a global extinction, but it would annihilate all life across an entire region of the planet. Millions of victims, continents reshaped, a planetary scar visible from space. On Friday, April 13, 2029, Apophis will pass at roughly 31,000 kilometers from Earth, 10 times closer than the Moon, and within the ring of our geostationary satellites. At that exact moment, it will pass over the Atlantic Ocean near the west coast of Africa. Millions of people will be able to look up and see, with the naked eye, a bright point streaking across the sky, as luminous as a star in Orion. It will cross the heavens in less than 2 hours, accelerated by Earth's gravity. A unique spectacle that will not happen again for another 1,000 years. For scientists, it is an unprecedented opportunity to observe a large asteroid up close without the need for a capture or deflection mission. But in fact, 2 missions are already on their way. After returning samples from the asteroid Bennu in 2023, NASA's OSIRIS-REx spacecraft was redirected toward a new target, Apophis. It now carries a new name, OSIRIS-APEX, short for Apophis Explorer. Its mission, to rendezvous with the asteroid a few months after the flyby and study it for 18 months. It will analyze its surface, measure its rotation, and even attempt a risky maneuver, firing its thrusters near the surface to stir up dust and reveal the material hidden beneath. Meanwhile, Europe is preparing the RAMSES mission, which will accompany Apophis during its close approach to Earth. Its instruments will observe the effects of Earth's gravity on its structure, rotation, and terrain. Such direct observation has never before been possible. As researcher Patrick Michel put it, for the first time, nature is bringing an asteroid to us. All we have to do is watch. But one detail makes this story even more unsettling. During the 2029 flyby, Apophis will pass near a tiny region of space, only a few hundred meters wide, the gravitational keyhole. If the asteroid were to pass exactly through that zone, Earth's gravity would alter its orbit just enough to set it on a collision course for its return in 2036. A minuscule chance, but not zero. That's why astronomers multiplied their observations using instruments such as the Gaia Space Telescope to reduce the uncertainty to just a few kilometers. In 2013, and again in 2021, new radar campaigns confirmed Apophis will not pass through the keyhole, no risk of impact, neither in 2036 nor in the next 100 years. The story of Apophis has profoundly marked space research. Before 2004, most governments saw the threat of asteroids as a theoretical curiosity. But Apophis changed that. For the first time, a concrete, measurable, short-term threat appeared in astronomical calculations. In 2016, NASA created a dedicated division, the Planetary Defense Coordination Office, responsible for detecting, tracking, and, if necessary, deflecting hazardous objects. This awakening led to new projects. The NEO Surveyor Space Telescope, designed to detect dark asteroids invisible to optical telescopes, and the DART mission, which in 2022 successfully altered the path of a small asteroid. A test followed by the European HERA mission, set to analyze the results in detail. Today, astronomers have identified over 30,000 near-Earth objects, of which nearly 2,000 have even a small probability of future impact. And the great question is no longer if an asteroid will strike Earth, but when? In a year? In 100 years? No one can say. But one thing is certain. Since Apophis, humanity has opened its eyes. We now know that our planet is neither isolated nor eternally protected, and that our survival may one day depend on our ability to predict the unpredictable. On April 13, 2029, as Apophis silently glides above our heads, some will see a threat, others a warning. But for scientists, it will above all be a reminder. Our world is just a fragile stone, adrift in the immensity of the void. And within that void, other stones travel, some far closer than we imagine.